When you're using the product and the quotient rules with your log functions, just do the same thing that you normally would. You need to identify your u and v parts and then apply that product or quotient rule formula. So here we'll need to use the quotient rule because we've got two parts and each one is a separate function of x and they've been multiplied together. So that means we're after the product rule. So simplest way to make sure you don't mess anything up, identify your parts. If u is x cubed, then u dash will be the differentiation of that, 3x squared. And in v, don't forget the notation here, this just means the natural log, which is a log with base e. So you can write it as it's being given, or if you prefer, you can write it like this. And we know that when we differentiate that, we get 1 over x. Now it's a matter of putting it together, dy dx equals, now you don't need to write this line out, but in case you've forgotten it, v u dash plus u v dash. So that means we need to do v multiplied by u dash, so 3x squared multiplied by this. I'll write the simple thing first, and then the log, plus u times v dash. Now you can multiply these together here like this if you like, with a dot between or a little times sign between, whatever you like, or if you can see in your head that you can simplify that really easily, then it's fine to do that working in your head and say we've got x squared here. Up to you, it's just a time saver. If you haven't fully simplified it, on the next line you'll need to. Now, you'll notice that often with the product rule, we can actually factorise. And it's worth doing it because often you can then simplify what you're left with and get a much better answer. So here we can bring x squared out the front, and that leaves us with 3 multiplied by the log of x plus 1. Now, you can play around with logs all day sometimes, just changing them into different formats. Once you get to a format that's simple enough, leave it there. But just be aware of those different disguises that your answer could have in case you're looking in the back of the book and you're thinking you might have it wrong when yours is just written a different way. Remember how malleable logs are. We could change this expression inside the brackets using the power law into the log of x cubed plus 1. We could even change 1 and write it as a log. This is just the log with a base e of e. Now that we've got our bases the same, we could actually even combine these logs. And if we're adding powers, because a log is a power, we must be multiplying the bases. So this is actually the same thing as x squared times the log with base e of e times x cubed, which you could write ex cubed or x cubed e, either way around. So there's lots of different forms of the answer. I mean, you could then even use the power law to bring this x squared up the front here. So tons of different disguises, but don't waste time with all of that. I'd actually just stop here. Now for this one, we need to use the quotient rule because we have two entire parts of our function and both of them have a function of x. Now it looks like a really simple question, but one like this has a few places where we could make a mistake. Once again, I'm going to list all the ingredients I'll need for the quotient rule. So u is this part on the top. Now you can write it as a natural log like that, as in the question, or you could write it with a log of base e, up to you. So we have all of that as u, and v is whatever is on the denominator, so that's x. Now this one's really easy to differentiate, we just get 1. This one, when we differentiate it, we will get the differentiation of what's in the brackets, which is just 1, over the function itself, x plus 1. So now we have our 4 parts, we're ready to apply the quotient rule. Now you don't need to write this line out every time, but if you're finding that you're forgetting it, write it out a few times till it's in there. Make sure you get things the right order. vu dash minus u v dash over v squared. So that means on the top, we need to have x multiplied by 1 over x plus 1. Well, I can write that as x over x plus 1, just multiplying those two together in my head and letting the x sit up there on the numerator. Then we need to subtract u multiplied by v dash. Well, one lot of this is just itself, so I just need to write this part now, log with base e of x plus 1, which I could also write ln, natural log, x plus 1. Now I need to divide by v squared. So if v is x, I need x squared on the bottom. Now it's not okay just to leave it like this because we've got a fraction over a fraction. So we know we can do better than that and simplify it somehow. Now the easiest way to think this through is to get rid of the fractions. We need to multiply all of the parts by that denominator. And if you struggle with one like this, think what you might do with an easier question. If I had something like a half minus, 5x all over something else. If I wanted this not to be a fraction, how do you get rid of halves? You'd multiply by 2, wouldn't you? So if I make this part twice the size and change it from half into 1, and make this part twice the size, and make this part twice the size, I've doubled everything. So it should be in proportion. But make sure you are doubling all 3 parts, 1, 2, and 3. You can't just pick and choose some of them. Now, in our example over here, we don't have a nice simple number like 2 to multiply by. We need to multiply everything by x plus 1. So when we do that, we're going to get this first term is just going to become x because we've multiplied by its denominator. So that will disappear it. This next term needs to be multiplied by x plus 1. Now be careful, because if you write it like this, it might look as though we're taking the log of this whole section here, this whole quadratic sort of part. And we're not. We just want x plus 1 multiplied by this. So it's much safer to not get confused and make it very clear to write it like this, because that means something different from what I had before, which was a bit ambiguous, could go either way. Now I need to multiply the bottom also by x plus 1. And now I can leave it like this. This is good enough. I can't easily factorise on the top, and I can't cancel these x plus 1s on the bottom because this one doesn't have an x plus 1 to give, and that's the reason we multiplied everything by that anyway. So this one is good and we can stop here.